I think so. We should start now. Initially, I give you introduction first. So, welcome everyone, and good evening, everyone. Good evening, sir.
Good evening.
I am delighted to introduce Dr. Kamal Priti, sir, Associate Professor. He's working as Associate Professor in the Department of Computer Science and Engineering at Christ University, deemed to be University Delhi. Uh, Urpiti sir have completed his PhD, BM, MTech, and PhD, and teaches across the different domain of computer science, mathematics, and statistics. Sir have published more than 50 patents, 32 magazine issue, and 154 research paper. His area of interest a wide range of fields like modern physics, data analytics, cyber security, machine learning, healthcare, embedded system, and cloud computing, and a lot more. So we are very fortunate that we have you as a faculty for this course. And sir, I heartily welcome you to my MCA program learner. So sir, now you can start with your session. Thank you so much, sir.
Thank you, sir, for giving a warm
Yeah.
introduction. Thanks a
Yes.
lot. So I can initiate that particular curriculum, I think so.
Right, sir.
Thank you. Sir, can you make me a host as well?
Yes, sir. I'll make you host, sir.
Okay.
You are host now, sir.
Okay. Okay, sir. I think my screen is visible to all of you.
Yes, sir. It is visible, sir.
Yeah, perfect. Perfect. First of all, good evenings to all of you. Before starting my presentation, I'm just giving a first 5 to 10 minutes. I'm just giving us some brush up about it for this particular subject. Why we are studying this particular subject and what we will do it after that particular studying for this particular curriculum. First of all, I'm give a special thanks to the Divya Patil, basically the University Vidyapeeth, and they are just design a very wonderful curriculum. Actually, it is a very vast and clarity of their thoughts and which the how the student can be able to wind up that particular track with a very fast track, I can say, because it is having a limited time duration is there for a 10 hours, but I can say it was designed very terrifically. Perfect. So before starting that particular session, I'm just giving a little bit introduce about that particular the course and driven, what is the use, what is the perspective behind it. So that particular subject is especially for computer organization, I can say. So computer organization, sometimes we are saying computer architecture, or sometimes we are saying computer organization architecture. All the threes are correlated to each other. So before starting of that particular content, I'm just giving it now that there is a one very famous book I can say, Morris Menu, because in the 10 hours for this particular curriculum, I just cover with the limited number of content which are existing, because I will just give a proper glimpse in which how we can try to study it about for the this particular curriculum. But if you want to be study for this particular book, particular curriculum in a detailed manner, I can say there is a very famous book that you can write it. The book name is Morris Manu, and it is available soft copy in a Google. It is a open access, no need to be pay anything. You should try to download your book, and it is approximately 432 pages book is existing. Okay, so if you are having a content, so whenever you are just getting a time, you should try to prefer to study in a detailed manner. Okay, so before starting it now, I'm just give a little bit about what we can do it in the course curriculum. It is basically for understanding of the principle of computer organizations and its architecture, how we can correlate with basically for its fundamental, which is very important. Okay, book name is Morris Menu, because someone is asked in a WhatsApp group, actually chatting. Morris menu, or otherwise I will share a link with all of you. Don't worry. Okay. It is a black in color book. It is a very good and it is very popular book, I can say. So in this particular code description, I can say we are just more focusing and studying about the computer organization, how we can organize that particular things as per the networking is concerned. What are the fundamental compute components are existing? How we can just try to interact with the, we can say, instruction set architecture, CPU design, memory system, input and output organization, pipelining, multiprocessing, and advanced computing architecture. So these are the basic things that we need to be focused on, which is very important. And next, I'm just coming with the course objective, which is very important because when we are just focusing for the course objective, it is something which is existing that we call as the fundamental concepts. So we can just try to focus on fundamental concept, which is very important. It is a computer organization architecture, including for historical evolutions and the basic architecture, which is very important. To enable the students, how we can design it for the digital logics. I can say digital logic is completely based on the concept we are having for 0 and 1. But for on the 0 and 1, how we can perform the basic fundamentals, okay, for basic fundamental units like and, or we can say not, and how we can club these particular gates and to make it the universal gate, which is very important. So we will discuss in the upcoming classes as well. Next is we are just focusing on design and the functioning of CPUs, control unit, and the memory system. Because we are having a different things are existing for CPU, control unit, and memory. Now the question is how we can just try to correlate it or all these things and make it become very functional. And next point, we are just focusing for addressing modes because there are different type of 7 addressing modes are existing. We will consider it in later classes. And next, this is a very advanced version which is going on that we call as a pipelining, multiprocessing, and emerging computer processing because there are a lot of emerging techniques which are existing, I can say. We can say cloud computing, grid computing, and there are a lot of things which are existing that I will just introduce in later classes as well. So in the unit 1, we are just focusing for computer organization and architecture. It is basically a basic fundamental because in this one first unit, you will just read it about we can say the architecture which is given by the father of a computer that we call as a von Neumann. Von Neumann is a professor, or we can say father of a computer, who has just given a concept how we can store your data inside a memory. Okay, storage concept which is given by the von Neumann. Next, in the data representation and number system, we will focusing on the other different type of number systems and are existing. Octa, binary, decimals, and signed, unsigned numbers are existing. We will consider it. Next is we are having a different type that we call as a floating point and floating point representations. Different type of representations which are existing, I can say. We need to be take care. Okay. Next is we will just focus for ASCII characters. ASCII stands for American Standard Code for Information Interchange. How we can use it, how we can just process it. And there is a Unicode which is very important, I can say. Unicode is basically used for, we can say, universal code. If you can just open your book or any barcode that you are just purchasing it now, so you will see at the back end, it is existing for barcode in your any component that you are purchasing. Now you're just going for anywhere else for purchasing any component, you're just having a barcode, it is attaching on it. You just click on it and you will be able to getting that particular information. What is the cost of that particular book? That we call as a Unicode processing that we are just performing. And then later on, we are just performing arithmetic operations. I will just tell you addition, subtraction, multiplication, divisions, how we can do it. And next is we will do it for Boolean algebras, because I just already told you we are having some basic gates are there and or not. We will just try to how we can just create a different type of dimensions, or I can say a different type of registers. So I will just tell you the other two categories are there. It is for sequential and second is combinational circuits. I will just illustrate you later on. In the unit 4, we are just focusing for control processing unit because what is happen whenever you are just teaching it about the CPU, we should know what is the instruction cycle which is executing in the backend. Instruction, decode, fetching, execution. Next is while we are representing your instruction, it is a two type, RISC and sys. RISC stand for instruction restricted instruction set computers. Again, I'm repeating. Restricted instruction set computers, and CIS stand for complex instruction set computers. So I will just tell you how we can categorize this, how we can work on it. Next is it is having an addressing mode because while we are representing your data in different platforms, it is a different way of addressing of your data actually. It may be immediate, direct, indirect. We will discuss. Next is instruction set architecture, which is very important. Because in case of instruction set of architectures, we need to be focused on which type of data we are just taking. It may be an arithmetic or it will be a logical. How we can just try to able to process it. It may be it may be able to execute for exceptional handling or not. And the last point, which is very important, we are just always be focusing for the complex instruction set computer and the restriction set of computers. Next, we are just focusing for control units because we are having a lot of design units are existing. But again, the question is existing, how we can just try to perform it. It is again in the unit 7, we are just going for a memory system organization, which is very important. We are having a different type of registers, cache memory, main memory, secondary memory, how we can represent for a segmentation, which is very important. Now, if I'm saying we are having a RAM, you should be know there are two types of RAMs are there. SRAM and DRAM is existing. In the chapter 8, we are focusing for input-output organizations. What is happen? In the input-output organization, it means we are having a system in which we are just performing interpretations. How we can create a DMA, direct memory access is there. What is the objective? What is the perspective? How we can just try to connect it, which is very important. Next is we're just going for pipelining and instruction set because what has happened? I will just tell you. There is a difference between the pipelining and instruction level parallelism. Because of the pipelining, we are having a multiple instructions which are going in a parallelized manner. I'm just giving an example. Suppose we are having a 5 stages are existing, another object it is having a 5 stages. If a one stage is executing for a one object, the second stage will be executed by the another stage. So it will be going in a parallelly for a multiple things in a one stage, in a one time duration. Next is multiprocessor system and the parallel processing because it is having a different type of systems which are existing. SISD, SID, the multiple things which are existing. Or we are just computing for parallel computing, channels and synchronization, which is very important. Because we are just performing for a parallel computing and challenges in synchronization, which is very important. Computer arithmetic, because we are having arithmetic operations are required, addition, subtraction, multiplication, division. How we can perform it, that we call as an ALU, arithmetic logic units, and how we can identify the error, detection and correction, which is very, there is a very concept for famous code that we call as a Hamming code that I will just tell you. Yes, there is another process that we performing a multiplication for a 6-bit, 12-bit and 20-bit that we call as a Booth multiplication. It is a proper way for doing a multiplication as well. Next is there is having some advanced topics that is coming in the boom in the market, I can say. First is the quantum computing that plays a wider role because while we are performing for a quantum computing, we need to be check it out. What is the brain emerging edge and fog computing, which is going in a very prolonged concept, which is going in a market, I can say. Along with that, there is some outcomes which are existing because if you can, while you are just working in a one particular course, it is having a taxonomy, Bloom's taxonomy. So in the Bloom's taxonomy, it is having a 6 layers. So we just trying to mapping with CU with respect to PO. CU stands for course outcome. So course outcome, it has always been designed on the basis of its content, how you are just getting it. So if you can see here, these are the standard books which are existing. Because please listen it carefully. Book number 2, that is the called as the serial number 2. It is very important. That is a M. Morris Manual. It is a very famous book. Please try to click on the Google, write it, open access PDF. You can easily able and to download that particular content. Okay, so I'm just starting my today's session. My slides are visible to all of you. Can anyone can confirm to me? Please, anyone can update. My slides are visible.
Yes, sir.
Okay,
Yes, sir.
thank you. And please check it. My slides are moving now. It is moving.
Yes, sir.
Thank you.
Yes, sir.
Perfect. So I'm just starting my content. It is basically for computer organization and architecture. So please understand my slides are a little bit more creative. I can say it is not having so much content. But if you can see, my slides are having a maximum number of keywords are existing. Okay. So try to correlate that particular keywords, which is very important. Okay. And if someone is having any doubt regarding for that particular concept, please kindly raise your hand or please ask to me, sir, kindly repeat and resolve my doubt. That will be more better, because I just want to make our session become more interactive. I don't want that I'm saying in a one side way. It should be a two-way synchronization, please. So before starting for a computer organization, I just say the computer organization is divided into three parts. First is organization and architecture. Second is a computer system. And third is computer evolution and performances. Now the question is coming, sir, because when I'm just delivering a session, there are a lot of students and the researchers who are just asking to me, sir, why you are just categorizing the main computer organization subject into the three main categories? So my question is, because by dividing the things in the form of category, you can easily be able to identify what are the benefits, what are the priorities, and what are the things which are important for us at a time of representation. So first I will say, I will just performing organization and architecture. It is just like representing for a structure or a one particular source. So while I'm representing anything in the form of a structure, that we call as an architecture. Second is I'm just going for a computer system, because why I'm saying for a computer system, because we are having a one particular system and we will be able to represent the thing in the form of a system. System is nothing. It's just like a collection of components. I can say we are having a multiple number of components that are existing, that we call as a system. And third is computer evolution and performances. What has happened? Because if you can see, there is a lot of changes and performances are executing. I can say a revolution is nothing. Evolution is nothing. It is just like a changes. Like if you remember that at once upon a time, we are using a computer just like a home. It is a bigger in size. Then later on, we are just reducing the size. And now we are using very small, lightweighted laptops. Just take an example, in the 10 or 15 years back, I can say we are using Pentium 4. And now we are using a series, third series, 5, 6 series, and 7 series. So I can say the revolution is basically going on for doing and changes. And if the changes will be occurring, definitely the performance will be improved it automatically. So I just want to be say and suggest that the performance, it is always be useful and fruitful in order to make our product, become more advantageous. Okay. So I'm just going to the next slide. Now, many a times we are just saying computer system is just like any system, consists of interrelated set of components. Please understand, we are having a lot of components are existing. Components is nothing, it's just like a device. What will happen if you are having a multiple number of devices are existing and we are just trying to connecting all the devices? It is just like a system. So system consists just like a multiple number of devices we are connected to each other. I'm just taking an example of computer system. Like in a computer system, you are having a mouse, you are having a CPU, you are having a monitor. These are basically the devices. And while we are connecting all the devices, it's becoming a system, which is important. Now, for going for a computer system, you are having a two things, that is an architecture and organization. So in the architecture, we are having a representation in the form of architecture is nothing. It's just like a representing a structure. If something you are having, how you can try to represent it, which is very important. And second thing, we are having an organization. Organization, it is always be targeting. If you are having a certain product is existing, how we can try to able to represent the things in the form of a representable form, which is very important. That we call as an organization. Now I'm just coming it out, which is a very important part that we call as an attributes. Because what has happened, we are having attributes. I can say these are basically parameters, I can say. We are having a certain number of parameters. Parameters is nothing, it's just like a variables. I'm just taking an example. When you are just purchasing any computer or anything that you are purchasing, before purchasing, you are just trying to identify what is the features, what are the configuration of that particular system. how much the RAM it will be, what is the hard disk, what is the resolution of the pixels, which device that we are using it, how much the part of a warranty which is existing. So these are basically we call as a parameters. Or we are always saying the parameters are always representing just like an attribute. So if you can see here, we are just giving a certain examples, I can say. Instruction set, that is very important because in the instruction set, we are having a certain number of values which are. Instruction is nothing. We can say instruction is just representing a set of values. If I'm just giving a one example that if you are saying I'm having a 1 byte, so 1 byte is a combination of 8 bits. So while I'm just clubbing for 8 bits, it is representing for a 1 byte. So another thing, we are just trying to representing the number of bits used to represent the various data types. I can say we are having a multiple number of data types are existing, but the question is how we can just try to use it. Okay. Third is input output mechanism, because we are having a multiple number of mechanisms are existing for its processing. Like I can say we are having a certain number of mechanisms like for its processing. What is the input? How we can just try to process it? What is the desired outcome which are existing? Which is very important. Input output mechanism is nothing. It's just like an input output life cycle which are existing. Last is memory addressing techniques, which is very important. What has happened? We are having a memory addressing techniques because we are having a lot of addressing switch. Addressing is nothing. It's just like a representation, I can say. We are having a multiple number of addressing approaches are there. But the question is how we can just try to represent these approaches in the form of a representable form. Now I'm just coming it out for the operational unit, which is very important because what has happened? The word we call as an operational. Operational means we are having a multiple number of attributes along with symbols. Like I'm saying A plus B. So it means we are having an A and B, we are having an attributes. And plus B we call as an operations. Like 2 plus 3. So plus representing an operation, it is performing an arithmetic operation. 2 multiply 3, it is becoming a 6. So 2 multiply 3, multiply it is representing an operator, I can say. So while we are performing for a different type of operations, along with that particular type of examples that we need to be required. Second is we are having an interfaces. Yes, because interface is nothing. It's just like a medium of a connection. I can say if we are having a computer and the computer is having a multiple number of devices. So the question is how the computer will be interact with other devices with the help of certain language. So how the system is having a certain language, it will be representable in the form of binary bits. And what is a binary bit? It is representing always from 0 and 1. Next is, I'm just saying how we can represent the memory technology. Please understand that technology, it is always be changing. Technology is always be changing. But the question is, when the technology is changing, the question is how we can try to update it, which is very important. How we can just try to update it. How we can just try to process it, which is very important. So I can say once upon a time, we are using for bits, bytes, kilobytes, megabytes, and now we are using for zontabyte, which is having a huge data set storage. Now, I'm just coming it out with the modern computers and content for millions of electronic components. Yes, I agree. Because if you can see, there are the millions of interconnection of their devices, interconnection of the components, who are just trying to communicate to one another. Okay. So on the basis of that, we can be able to transfer the millions of instructions in the fraction of second. Just a minute. Now, before going for structuring and functioning of a system, I just want to say that we are having a multiple number of, we can say, structure and functions are existing. So why I'm saying that there are a multiple number of structures are existing? Because the question is, structure is just like a way of representing the things, which is very important. There are different way of representing the things. There are different ways of correlating the things that we call as an interrelation, that we call as a structure. So again, I'm saying we are having a multiple number of components are existing and we're just trying to connecting these components that we call as a structure. Second is I'm just taking the function. Please understand, function is nothing. It's just like we are performing an operation. between the individual components. Because what is happened, we are having a multiple number of components are existing. But the question is how we can just try to connect with different type of operations to one another that we call as a function. So please understand when we are just performing for a certain actions, certain operations, we need to be take care how the functions are correlating to one structure with respect to another. Next is, I'm just coming a simple, we can say the diagram, I can say basic functions. So the basic function, it is always representing in the form of a data type that we are using, data storage, sorry, data processing that we are just doing. And the thing is, we are just trying to controlling the things, which is very important. Controlling the things means we are having a multiple number of options are existing to process. We are having a multiple options to process. And for a meantime, at a time of a processing, we need to be take care which type of a data storage that I'm just trying to processing, which is very important. Second is data movement that we call as a data movement. So data movement, it is always representing, we are having a different number of data are existing. Data is nothing, we are having a certain values are existing and we are just trying to connecting the certain data in order for its execution, like arithmetic, we are having a relational, we are having a logical, or we are having an arithmetic. So these type of data, when we are just trying to processing it with a different type of functions, then we'll be able to identify that it is a data mode. Second is, next is we are just going for a control. Control is always representing, because whatever the values which is coming inside for an input output life cycle, we need to be take care. We should get a sufficient number of input must be just going in a one particular instruction. And after the sufficient of input, we should try to get it for the sufficient number of outcome as per the desired problem, which is very important. Now, so my main agenda for it's just like processing is, I'm just coming it out. I can say this is a architecture that will be able to process it. First is the data movement apparatus. You can see here, we are having a certain data which are existing. For is called as an operating environment, that is the source and destination of a data which are existing. As per the data movement, we are having a data movement apparatus is there. Control mechanism is there. And along with the control mechanism, we are just trying to focus on data storage facilities. Because what has happened, we are having a multiple number of storage facilities are existing. And along with the facilities, we need to be take care how we can be able to process our data, how we can try to facilitate our data with the help of control mechanism. Okay, so I can say it is a two-dimensional process. You can see here, it is a two-dimensional process which are existing. I can say the same, either it is transmitting and it is transferring. It is transmitting, it is moving. So it is a two-dimensional way of processing our data in order to getting a desired outcome. So it is really very fruitful for us because I can say this type of architecture is specially designed for the non-human architecture. And on the basis of that, they are just representing in the form of an outcome. Okay. Yes. Now I'm just coming the next concept that we call as a computer top level structure. Now, if you can see, we are having a peripheries. Peripherals are existing. Peripherals is nothing we call as we are having a multiple number of devices are existing. We are having a multiple number of devices. But the question is, if we are having a multiple number of devices are existing, and I'm just trying to connecting with the peripherals with the computer, and computer is trying to connecting with the control processing unit, main memory, system interconnection, or input output devices. So if you are having a connection of all these systems, for CPU, main memory, system interconnection, input output, then we can say the computer is connected with all the devices. I can say. So I can say a computer is having all these things which are required for our product. It is having all the things. And the computer is having a multiple number of peripheries in which we are just trying to interact with them. We are just able to try to process these things that we call as in peripheries. And along with the computer, we are just focusing for the communication lines, which is very important. So communication lines means we are having a multiple number of, if we are having a system that we call as a computer, and computer is connected with the communication lines. Okay, that we call as a connection which are existing. Now, we are just coming with a discussion actually, if you can see. It is giving a certain interpretation, I can say. It is saying that in the upper, we are having a CPU that we call as a control processing unit. And the beauty of the control processing unit, it is always focusing for operations of the computer. What are the operations that we are having, which is very important. Okay. Second thing is, while at the meantime of an execution, we can say while at the meantime of execution of a processing or at the time of changing for an instruction, I can say, we need to be take care that how the CPU is executing, which is very important. And the second thing is whatever the instructions which are executing or performing it. Okay. We need to be take care. What are the main thing which is need to be processed? I can say. So we need to be take care while at the time of an execution or at the time of a processing. We need to be perform it, what the instructions which are executing, which is very important. And second thing is while at the time of meantime of an execution of a memory, we need to be stored for a data, which is very important. So what will happen if you are having a main memory which are executing, we need to be take care what are the input output instructions which are executing, I can say, and how we can able to process it, which is very important, which is very important. So please take care. If you are having an input output devices are existing, and how I can be able to transferring that particular data between the computer and our external environments. Is it okay? So we are having a multiple number of devices are existing. So at the meantime of executing for a devices, we need to be take care that which computer is trying to interact with the external environment, which is very important. Which is very important and it is very crucial, I can say. Okay. Next point is we are just going for a system interconnection. Please understand. System interconnection, it is always be showing. It provides a communication about the CPU, main memory and input output. Because what is happen? If we are having a system is existing, if we are having a certain components are existing, what we can do, we just trying to connecting with all the threes. Okay. So on the basis of that, we will just trying to communicating to each other, which is very important. Okay. Now I'm just representing a main structure, which is very important. Because if you can see, I'm just coming it out with a certain diagrammatically structure because our human mind is having a good tendency for visualizing the things instead for reading the things. So that's why I'm just coming to make our slides become more interactive and more talkative. Okay, so that you will be able to understand the things. So I'm just coming it out the brief architecture for a control processing unit because we are having a multiple number of systems are processing. We are having a certain number of instructions we are just performing. But the question is at the meantime of control processing unit, I need to be take care which type of the instruction that I need to be processed. So you can see here, we are having a certain number of input output devices are there. System bus, please understand, system bus is a very important device. Very important device. System means connection of wire. If we are having a huge, please understand, bus is nothing, it's just like a wire. Bus is just like a wire, I can say. And while the wire is used to connect the multiple number of components, it is making a system. And while the system is connecting with respect to bus, that we call as a system bus. Please understand and please note down, bus is a interconnected wire, which is basically used to connect the devices. Or in a short, I can say, bus is nothing, it's just like a wire, which is basically used to connect the systems. Okay. Now you are just see here, there is a very smallest unit of a CPU that we call as a register. Okay. That we call as a register. So the question is, what is register? Register is a device which is used to store only one bit of information inside a circuit. I'm just giving a very good example. If you can see, because it is nearest, because if you can see in your home or everywhere, you are having a plug on and off of a switch. We can say switch, because once you can click as on, your fan will start running. And if it is come off, your fan will stop running. So if you can see, once you can click on it, your fan will start. So it means you are giving an instruction. It will be an on. It must be an on. And instruction will be one. Okay. Now in the another case, if you are just putting it close, it will be an off. While putting it close, it will be an off. It means we are giving a zero instruction. So it means it is a device which store only a one bit of information that we call as a register. So register is basically used to store only one bit of information. Okay. Now we are just performing for arithmetic and logical units, we can say, because in arithmetic and logical unit are basically used to store only a bit of informations, either for plus, negative, minus, and so on. Okay. Next is we are just going for internal CPU connections, because we are having a internal control processing units are there, and the different internal CPU connections are there. They're connecting to each other. So we can say we are having a different connections which are existing. And what will happen if we are having a multiple number of connections are existing, then we will be able to connect to each and one component with respect to another. And second is we are just using for a control unit. Yes, because the control unit is basically just like a unit basically used to take care the registers, take care the arithmetic and logical units, and take care for internal CPU connections. Now, I'm just coming the detailed illustration. If you can see here, control unit is just like performing for responsible for instruction executions. Because instructions, I just already told you, you are just giving an idea how we can just try to process it, either 1 or 0, 0 or 1. Arithmetic and logical unit, because we are having a computer and we are just trying to processing a data, either we addition, subtraction, or multiplication. And now we are using for a register, because register is basically used to store into the CPU as well. Now we are using for the CPU interconnections, because we are having a multiple number of components are existing for communicate, either for control unit, ALU, and registers. Now, again, it is because initially at the previous diagram, if you can see here, it was mapping for a CPU, and now it is a mapping for control unit. Please understand. They are the multiple, because each component plays a very crucial role, especially for mapping of the components. Because what is the beauty for a control unit? Control unit is just trying to connecting with the other devices as well. So with the help of control unit, we are just trying to interacting with other devices as well. Like sequencing logic. Sequencing means we are having a multiple number of units are existing, multiple number of data is existing. And what we can do, we can just try to connect all the sequences in the form of information. And next is, I'm just coming with a control unit register and decoders, because what is happened, we are having a control unit register and decoders are existing. So the question is, if we are having a lot of information, control unit registers are existing, how we can just try to connect with all of them, which is very important. Next is, I'm just using for a control memory, because we are having a multiple number of memories existing. But the question and the constraint is how we can just try to interact with them, which is very important, which is very crucial. So the beauty of the control unit, I can say this is a main part of a processor, which is very important. Because we are having a main part of a processor, I can say main part of a processor means processor, I can say it is a control unit is the main part of a processor. I can say why it is saying it is a main part of a processor, because it is a core heart of an operating system. Same in this case, it is a core part of a computer system. So it performs the task repeatedly, cycling through the following steps. Because we are having a multiple number of stages are existing. But the question is, while we are just performing for a multiple number of stages, we need to be take care how we can able to try to execute that particular process, which is very important. So first of all, we should try to read the instructions from the memory. we should try to read the instructions from the memory, because what is happened, we are having a multiple number of instructions which are existing. The question is how we can try to read from the next instruction from the memory. So for going for the next instruction, we are just trying to examine the instructions to determine what it is and to identify any possible errors. Please take care. We are having a multiple number of instructions are executed. But the question is, we need to be identify which type of the errors which is coming at all. This type of error means they are having a multiple number of problems are executed. Problems means there is some mistakes, some issues, some difficulties they are just facing it now, how we can just try to process, which is very important. Next is execute the instructions, which is very important, because once we are just read it, after the reading, we are just examining the things. And after the examination, we are just going for executing. Okay. So we can say it is a 3-stage process of a cycle which we need to be processed. First is read it. Second is examine it. And third, we can just try to execute. So read, examine, and execute. They are the 3-stage layer of processing that we are basically used for its instruction execution. Okay. And now I'm just coming it out the computer system. Okay. Because what has happened, we are having a multiple number of computer systems are executing. So in the computer system, it is having a top level. I can say the computer system, it is a computer which is consists of CPU. We are having a memory, and we are having an input-output components. Okay, again, I'm repeating. We are having a control processing unit, the memory, and we are having an input-output components. And what will happen? These components are just trying to correlate it one with respect to another. That we call as the different modules which are existing. So when these modules are existing, what we are just saying, we are just trying to connecting to one with respect to another. Next, I'm just coming it out to the computer component, because what is happened, we are having a lot of components which are existing. But the question is, what is the cycle of, especially for the computer component, that plays a very important role. The concept that we call as a von Neumann architecture, because again, I'm saying von Neumann is the father of the computer. Von Neumann, we call as a father of a computer, because the beauty of the von Neumann is he gave a concept on the basis of 3-layer architecture. What is data? How we can store it. Second is how we can address our memory in a one particular location. It means how we can try to store that particular memory in a content. And third is how we can execute the things in a sequential manner. How we can execute the things in a sequential manner. Why I'm saying it is a sequential manner? Because every cycle, it is having a starting to ending process. Every cycle, it is having a process which is called as a starting to end. So the question is, if we are having a certain data that we need to be stored it, how we can just try to process it. So the question is how we can just able to try to store that particular data. So while we are reading, writing, and storing a data, and after storing, we can go for an execution that we call as a von Neumann architecture. Now, I'm just coming it out, the computer components, which is very, very important, because what is happening? We are having a certain number of components which are existing. But the question is, if you are having a multiple number of components which are existing, we need to be take care how there is a particular component that we need to be performed. Okay. Okay. So please take care while there is a particular computation that we need to be performed, we need to be take care that how it will becoming a more constructive. How we can say it will be a more productive, which is very important. So we need to be take care at the meantime of execution. We need to be check it out. What are the logical components are existing for a designing? How we can able to try to process it? And the second thing is, if we are having a multiple number of components, how we can just try to performing the programming inside it. Next is we are having a multiple number of computer components are existing. First is the hardware component, and second is a software programming component. So in the hardwire, we are having a certain logic components are existing, which is performing for arithmetic and logical components. Because we are having a lot of arithmetic and logic operations are existing. But the question is how we can just perform a processing, which is very important. Second is we are just performing sort of software programming, which is very important. Because we can say we are having a sequence of code of instructions. Because we are having a multiple code is existing. But the question is if we are having a multiple number of code is existing, how we can just try to processes between the hardware with respect to software component, which is very important. Okay. Yeah. I'm just coming it out. We can say there is a structure which are executed, which are available. So if you can see here, there is a one structure which is available that we call as a CPU. CPU that we call as a control processing unit. We are having a certain part that we call as a control processing unit, which are executing. And in the control processing part, we need to be take care for the input output modules, which is very important because we are having a multiple number of modules which are existing. And the question is when we are just connecting for an input output module with respect to CPU, how we can able to identify the main memory, which is very important. So I just want to say and recommend it, whatever the data that you are trying to storing it now, we should try to process it. So you need to be check it out that the instructions 0, 1, 2, 3 memory instructions data we are having or all these things are executed. So the question is if we are having all these things which are executing, we need to try to process it, how we can just try to able to process it, which is very important. First is that we call as a PC, that we call as a program controller, which is very important. IR we call as an instruction register because what is happened, we are having a lot of instructions which are executing. So at the meantime of when we are just processing for an instruction, we just trying to identifying a solution. Next is MAR stand for memory address register because we are having a multiple number of memory which are executing. Memory buffer register because we are having a certain memory which are executing for storing a buffer. Next is input output address register because we are having an input output devices are executing and along with a particular address that we need try to incorporate, which is very important. And next is the input output buffer register because what is happened, we are having a lot of buffer is existing. But the question is if you are having a certain buffer, how we can just try to process. Buffer is nothing, it's just like a storage space where we can store a data for the future use. That's it. Now, it is representing components that we need, which is need to be perform and execute it now for its effective approach, which is now need to be performed in a effective approach. Okay. So while at the meantime of performing for an input output component, we need to be check it out how we can perform for input output component, which is important because which data that I will be able to process it, how we can just try to process it, what is the effective outcome, what will be the effective outcome, what is the desired outcome, what will be the desired outcome, which is very important. And the thing is for getting a desired outcome for a signal, we need to be try care. We need to be try or perform its an execution, which is very, very important for us. Okay. Now, at the meantime of an execution, at the meantime of processing, it is having a component that we call as a main memory. Which is very important. So the question is, if you are having a main memory, we need to be target that how we can just try to process it, which is very important. Process it. So for the main memory, it is always be targeting what is the input and output which is need to be processed, which is very important. So main memory, it is basically used for storing the instruction, which is very important. How we can store an instruction, how we can just process it, what about the data which is need to be required, how we can just get a desired data, which is very important. So you can see here, there are the different type of data which are existing for its execution. So the question is how we can just try to process it. What will be the required outcome, which is very important. And the question is, if we are just trying to processing a data, we need to be tried for a signal, because please take care. Whenever the data will be stored, it is just try to getting a data in the form of a signals. You can see here, we are having a multiple number of data is existing, and along with the data, we are having a certain signals. So I'm just coming it out, the main thing that we call as a computer components. While using for a computer components, it is for certain category which are existing. Certain categories, I can say. So in the certain category means memory address register, which is very important because we need to be stored the memory, which is very important. Memory buffer register, because what is the meaning of memory buffer register means, because memory address register means we just trying to store an address for a memory, which is very important. Memory buffer register means we are having a certain buffer, and on the basis of buffer, we should try to store for a data. Next is we are performing for an input output registers or input output buffer registers. So input output address means we are having a certain instruction which is need to be tried to store it, which is need to be required to be stored for an address, which is very important, because what has happened while we are storing for an address, we need to be take care how the address we need to be stored. Next is we are just performing for an input output buffer registers, because what has happened, the beauty of a buffer is we are having a storing for a data, and we need to be tried to store for a data for a future use. Now I'm just coming it out for the computer function, which is very important, because the computer function is that is having a first started, fetch the next instruction, execute, and is halt. So same in this case, we will start that particular instruction, process it, and after the processing, you can see here we can fetching that particular instruction, fetching the next instruction, execute it, and after the execution, we are just getting the same cycle. So we can see the same cycle which is repeating again and again for its execution. Because we are having a certain cycles, we just try to process it and get it. Please. Okay. Second is, please take care, we are using a condition we call as a halt. So my question is, what is the meaning of halt? Halt means we are having a value which is trying to execute it. At the meantime of executions, it will be executing, not an issue. But if you are getting a desired outcome, it will be a full execution. And sometimes what has happened, we are just trying to executing now, but due to some reason, the things are going on hold situation. Or it will be going for a finite waiting condition for a one particular situation. That situation what we call as a halt. Now I'm just coming it out for the computer functions, because what has happened, because while at the time of an execution or processing, we are having an instructions from the memory. Because we are having a multiple instructions, and what we can say by getting an instruction from the memory, that we call as a processing. Second is program counter, because the beauty of a program counter, it is basically used to hold the address. Because we are having a multiple number of addresses are there, but the question is these type of addresses, how we can just try to fetch it out, which is very new. And next is we are having a processor. A processor is always be indicated for the increment the PC. PC stands for program counter. Because what is happened, if one instruction is executed, it will just trying to performing for a next instruction, next. So what will happen, it will increase the value one after the another. Okay. Next is fetching the instruction. Fetching the instruction means we are just trying to loading a value into certain register. Okay. That loading a value inside a register, that we call as an instruction register, which is very important. That we call as an instruction register. So we can say instruction contain specifically the set of action that we need to be processed. interpret the instructions, and perform the required action, which is very important. Because what is happened, we are having a lot of instructions that will need to be performed. But the question is, at the meantime of performing an instruction, which is need to be take care, which type of the action that I need to be processed. And now I'm just coming at the main concept that we call as the 4 categories we are having on it. First category that we call as a memory. We are having a memory, processor memory. The beauty for that particular processor memory is processor is sending an instruction to store it inside a memory. So either processor is giving an instruction to the memory, or either we are just trying to storing memory to the processor. So both which is going for a vice versa. Next is processor input output. Why we are focusing for the processor input output? Because we are having a data and we just need to be transfer a data from the peripheral devices or either from between the processor or the input output modules, which is very important. So we need to be take care either we are transferring a data between the processor or input output modules. And next is we are just performing for the data processing. So data processing is just like we are performing an arithmetic and logical operations on data, which is very important because we are having a multiple number of arithmetic and logical operations which are existing, and we just try to process it. And next is we are just performing for instructions that we need to be performed, the sequential of execution, which is need to be required. Because the beauty of a control function is we are having a lot of sequences of instruction are existing. But the question is, whenever we are having a certain set of instructions that we need to process, that we call as a control of an instructions. Now, if you can see here that we are having an interconnected structure. So the good thing of interconnected structure is that we are having a certain memory, and in the memory, we are just performing for read, write addresses and data we are having. Process it in the form of a memory, save it in the form of a data. After getting that required data in the form of a data, we just try to process it again from the input output modules. After processing for an input output modules, we are just trying to getting a desired outcome in the form of a CPU. So we are just giving an instruction, data, and interpret the signals. After processing it now, we are getting a desired outcome in the form of addresses, control signal, and data. So it is the best way of representing for interconnection of a structure, which is very important. Now you should take care how we can just perform the interconnection structure, which is very important because we are having a lot of interconnection structures are existing and it is basically for categories for it. So how we can just process from memory to the processor, processor to the memory, input output processor, and processor to the input output and input output from the memory. So I just want to say that we are having a certain set of instructions which are need to be executed. So in this case, we are having a memory which is existing and memory just try to process it in the form of processor. Same in this case, processor is giving an instruction to the memory and input output devices is giving the instruction to the processor and processor is giving the instruction to the input. So we can say it is just like a hierarchy which is going on for the multiple number of devices, I can say. So I'm just coming a very crucial part, I can say. Sys-bus interconnection. So I can say it is the next topic that we need to be try to process it, I can say. Okay. So we will continue this particular concept in the next class. So we are having a 5 minutes time as there. I think 3 to 4 minutes are existing. So I just want from the students that you should ask your queries. Whatever I just illustrate you about the components, the devices, or we can say how we can just perform the interconnection between the components, how we can just try to use the devices. If anyone is having any query, just you should try to raise the questions and ask to me, please.
Yes, learner, you can post your questions into chat box or you can directly unmute yourself and you can ask question directly to the sir one by one. Please.
I think I will, yeah, please, yeah, great, yeah. I think the person name is Hariom Kumar, and yes, he's asking a very good question. Actually, sir, can you tell me components? Okay, Yes, good. Because he is asking very good question, I can say. I just appreciate you. Components, I can say component is just like a small device. It's just like a register. Because I just already explained you, register is basically a device which is used to store for one bit of information. Okay. So if I'm just performing a collection of a registers, 1,000 registers, I will just connect it and creating a one device that we call as a component. I'm just giving another example to all of you. If you can say, while you're just purchasing your system, computer system, why we are saying system? Because it is having a multiple number of components. CPU is a one component, monitor is a one component, mouse is a one component, your every device is a one component. Now you can think it about what is a component. If you can see in a mouse, they are the 100 plus registers are existing. If you can see your keyboard, 104 104 keys are existing, and each key perform it just like a register, on and off. So I can say component is a collection of registers, and each register is a collection of input output unit. Is it okay? Because we should talk with the technical terms, because we are studying it about the computer organization architecture. Anyone is having any queries? Okay, no problem. I am just sharing my mail ID in a chat box. Okay. So if anyone is having any doubt, please kindly share your queries in this particular mail. Actually, definitely I will revert you, because I'm really very appreciating, because in the last sessions that I have just taken it, approximately 7+ queries the students has to be raised it. And out of 7, the 5 students are not students, they are basically the working professionals, I can say. And they have asked for the multiple queries and how we can raise it. So I'm really very happy if you can ask the questions with me on a mail whenever you are just getting, and drop a mail, I will definitely revert you. Okay, there are the 2 queries which is coming it out, how we can calculate the values of a register. Yes, it is a good question that has to be asked. Register is just like a collection of, it is only performing or storing for a one bit of instruction. Okay, that is 0 and 1. And he asked how to calculate the value of a register. For calculating the value of a register, I will just tell you, because I've just already explained you in the unit number 7, when I was just illustrating you the content. They said, we are performing the calculation value of a register with the help of Boolean mathematics. We are performing with the help of Boole algorithm. So I will tell you how we can performing a multiplication. It will come in the later classes as well. There is a one question that has to be asked, sir, what is halt and how it is responsible? Halt is just like a waiting time actually. Suppose you are just executing for a certain instruction, and what will happen after the execution for a certain instructions, your system is coming at just like an, I can say, halt stage. Halt stage means in the waiting stage. It will be scrolling just like, but the instructions are not executed. So what will happen? When a system is just going for a waiting stage, or they need some time to process it for a certain instruction, that we call as a halt. In a short word, I can say halt is an example of limited time duration break, or it will be taken by limited time by a processor to execute that particular instruction, that we call as a halt. Okay. So it is all from my side. I hope that everyone should try to study for this particular unit number 1. And I hope that everyone has enjoyed that particular session. So please try to work it out. And again, I'm saying if anyone is having any query, I'm just already shared my mail ID. Please drop your queries. Definitely, I will just take 24 to 48 hours time. Definitely, I will revert your queries. So it is all from my side. Sandeep sir, if anything that you want to.
Yes, sir.
Yeah, please.
Thank you so much for this wonderful session, sir.
Thank
It's
you,
great information to the learner as the beginning of this course. And you have explained very well each and every concept in a very simple manner, as well as with the diagram. So we actually seen very less diagrams in the PPT, but we have included a lot of diagrams, and this is the only way learner can get idea of the gist of the topic. So this is very wonderful, sir.
Thank you, sir.
So I just want to say thank you for this session, sir. And
you.
I think we should wind up this session. And thank you, learners, for joining the session. Thank you so much, sir. Thank you, everyone.
Thank you, sir. Thank you. Thank you.
Yes, sir. Okay, sir.
Thank you, everyone.